Hello, so this is going to be the last video we do tonight on volume. Tomorrow I will hopefully upload some videos for you on circles and on surface area, and hopefully also something on working with composite shapes and a little bit of problem solving. But we'll finish off volume by looking at the concept of liquid volume, or the other word we tend to use for that would be capacity. But if you were to pick up a bottle of water, you're going to look back at it, it's not going to give you a volume measured in cubic centimeters or cubic millimeters or cubic meters. Okay, water or any other liquid is always measured using things such as ml for milliliters or L for litres. Now, there is a relationship between liquid volume and the volume that we're used to in terms of using cubic units. Historically, it was originally defined that 1 litre of water would be what was called a cubic decimeter of water, that being the amount of water that can fit inside a cube that is 10 centimeters by 10 centimeters by 10 centimeters. And the definitions can be very strict in science. They're talking about the amount of water at a standard temperature, ocean water being around about 3.9 something degrees Celsius. But to make things a little bit more straightforward in maths, we're just going to use a mathematical definition, and we are going to say to you two things. We are going to say that 1 milliliter is exactly the same, or close enough for our purposes, as 1 centimeter cubed. So if you're asked to work out volume, you're asked to work out the volume of an amount of liquid, you can use your formulas to work it out in centimeters cubed, and then you can just change centimeter cubed in your answer to milliliters. The other thing that you might be asked is to give an answer in litres. So for that, you have to think about the relationship between milliliters and litres, which is that 1000 milliliters is exactly the same as 1 litre. So if you have an answer in milliliters and you're asked to give it in litres, then you would divide by 1000. If you have an amount of litres and you're asked to change it into milliliters, you would multiply by 1000. Now, what this brings me to, very, very briefly, is just a little hint. Whenever we're doing liquid capacity, it's really important in terms of units. We work in centimetres. Okay, you can convert from cubic meters into cubic centimeters and things like that, but it's harder and it's easy to make a mistake, so just move everything into centimeters right from the start. Okay, let's look at what this is like in practice. Okay, so I've got this blue shaded cuboid, and we know how to measure the volume of a cuboid. We do length times breadth times height. So one problem that I put to you in class recently was, I thought, let's see how much water, how many litres of water would fill up a bath. And I think we agreed that the dimensions I used for the bath maybe weren't the best in the world. So I had a little look on B&Q's website, and I found a good example of a normal sized bath being 1.7 metres long and being 0.7 metres wide, and that'll do for what we're doing at the moment. How deep it is depends on how you like it. So let's just say we're not going to make it an incredibly deep bath. Let's say that we're going to make it 50 centimetres deep. That may actually be quite deep, but we'll see. How much water, how many litres are going to fill up this cuboid to represent the bath? We have units that aren't quite as we would like. 1.7 litres is 170 centimetres, and 0.7 metres is 70 centimetres. So these now make sense to us, and we can work on what we'd like to do. So let's look at doing this. So V for the volume in that bath is length times breadth times height, which is, let's look at the order I'm going to try and do this in. That is 170 times 50 times 70. Okay, I'm going to work this out now. I promise I am not using a calculator in the background, but I'm going to try and do this a little bit in my head, so you could write down a sum. That's not a problem. 170 times 50 times 70. So let's use a little shortcut where we are going to think about, we split 170 up into 17 times 10 and 50 up into 5 times 10 and 70 up into 7 times 10. What we're going to do is multiply 17 by 5, take our answer, multiply that by 7, and then multiply our answer by 10, by 10 and by 10, or put 3 zeros back on if we want to use a little trick. So 17 times 5 would give us 85. I have to think there for a second. 85 times 7, I'm not going to try and do that in my head. I could, but I think I'm going to make a mistake. So I'm going to do 85 times 7 as a good old-fashioned written piece of multiplication. 7 5s make 35, so 5 and carry my 3. 7 8s make 56. Add my 3 to make 59. So my answer to that volume will be 5, 9, 5, 0, 0, 0 cubic centimetres. This is about to become really, really terrifying. 595,000 cubic centimetres, which, if we think about capacity, is 595,000 millilitres, or 595 litres of water. That is really terrifying when I come to think about it. If you want to stop there, you have a method for working out the liquid capacity of any container. You could do it with a cuboid, you could do that with a prism shaped container. I'm going to put a little Easter egg at the end of the video. I'm going to look and see how much water it takes to fill an Olympic sized swimming pool. That's where things are going to become really, really worrying. But if you want to stop there, that'll give you everything you need to do this. If you want to keep on watching, then have a little bit of fun. Okay, what have we got here? Olympic sized swimming pool. I looked up on Wikipedia. Being defined as 25 metres wide, 50 metres in length, and between 2 and 3 metres deep. I've said 3, just to make the numbers a little bit more scary, I think. So this would be the example of a swimming pool, not unlike the one built at Toll Cross for the Commonwealth Games. 3 metres, 300 centimetres. 50 meters, 5,000 centimeters. I begin to think that immediately this is going to be really, really terrifying. 25 meters, 2,500 centimeters. Okay, so we've got our dimensions in centimeters. Okay, so our volume is going to be length times the breadth times the height. It's going to be 2,500 in this case, times by 50, let's go by 5,000, multiplied by 300. Okay, and I'm going to use my little trick here. I am going to think of 2,500 as 25 times 100, or 5,000 is 5 times 1,000, and this 300 is 3 times 100, so I only have to multiply 25 by 5 by 3, and then I have to multiply by 100, then by 1,000, and then by 100. So again, in terms of shortcuts, I am going to add on 1, 2, 3, 4, 5, 6, 7 zeros to my ending answer. So 25 times 5 is 125, and if I multiply that by 3, I'm going to get 375. Okay, how many zeros was I adding back on? 1, 2, 3, 4, 5, 6, 7. Gosh, that looks like a big number. It's a wee bit old fashioned, but let's put some zeros in just to help us out a little bit. 1 there, 1 there, and my 1 there. So that is 3,750,000,000 centimeters cubed. I'm not going to rewrite that and say milliliters, but I'm going to change it into how many liters of water fill that swimming pool. That would be 3.75 million litres of water to fill up an Olympic swimming pool. Nearly 4 million litres. Okay, nearly 2 million 2-litre bottles of water or liquid. I knew it was going to be big. I didn't think it was going to be anywhere near that big. That's really quite terrifying. But you can see how easy it is to then work out things like this using the skills we've already got. Thanks very much.